Good morning, class. This is Mr. Sunday Ahindero, your maths teacher for this class. Today, we will discuss indices. Indices. Indices is plural. Index is singular. Indices plural. Index singular. X raised to power A is an index. X raised to power A is an index where A is called the power or the index or the exponent. X is called the base, and you pronounce this whole thing as x raised to the power of A. In this topic, don't do anything without applying your laws of indices. As a result, we are going to start with the laws of indices. Laws of indices, the first one is when you multiply two indices with the same base, like in this case, x raised to power A times x raised to power B. You see the bases are same. You write one base, then you add the powers to have x raised to power A plus B. Therefore, x raised to power A times x raised to power B is x raised to power A plus B. Application. You have to simplify the following. 10 raised to power 5 times 10 raised to power 4. These are indices with the same base 10. So write one base and add the powers 5 plus 4, so that you have 10 raised to power 9. 10 raised to power 9 is 1 billion. Where coefficients are involved, like in this case, 2m raised to power 5 times 6m, you first express this m as an index so that it becomes m raised to power 1. Then you multiply the coefficients. 2 times 6 to have 12. You apply your law to solve m raised to power 5 times m raised to power 1, which implies writing one base and adding the powers, so that your final answer becomes 12m raised to power 6. Also, r raised to power 3 times r raised to power minus 2. You write one base, you add the powers to have 3 plus minus 2. Plus times minus is minus, and the solution becomes r raised to power 3 minus 2, which is r raised to power 1, and that is r. Law number 2. When you divide two indices with the same base, you write one base and subtract the powers in this order: first power minus the second power. Therefore, x raised to power A divided by x raised to power B becomes x raised to power A minus B. Application. You have to simplify the following using the law. Now, y raised to power 6 divided by y raised to power 2. The bases are the same. You write one base, then you subtract your powers to have y raised to power 6 minus 2, the first power 6 minus the second one, and that gives y raised to power 4. Where coefficients are involved, like in this case, just like we did in multiplication, here you will divide. You will say 22 divided by 11 to give you 2. Then you apply the law, the division law, for your indices. B raised to power 7 divided by b raised to power 4. You write one base, then you subtract your powers because of division sign, which will give you b raised to power 7 minus 4, and your answer will be 2b raised to power 3. 9 times 10 raised to power 9 all over 3 times 10 raised to power 3. Here the coefficients are 9 and 3. So 9 divided by 3 will give you 3. You put your multiplication sign. Then you apply your law to this. 10 raised to power 9 divided by 10 raised to power 3 means 10 raised to power 9 minus 3. And this will give 3 times 10 raised to power 6. 10 raised to power 6 is 1 million. When you use it to multiply 3, it gives you 3 million. So is that you write your answer as 3 times 10 raised to power 6, or you express it as 3 million. And this 3 times 10 raised to power 6 is not the same thing as 30 raised to power 6. No. 30 raised to power 6 is not 3 million. So leave your answer as 3 times 10 raised to power 6, or you write 3 million. The third law, zero index law, x raised to power 0 is 1. Anything raised to power 0 is 1. Application, p raised to power 0 is 1. 3n raised to power 0. Here, the n is the one that will be affected by the power 0. So this n raised to power 0 is 1. And since 3n raised to power 0 is 3 times n raised to power 0, it will now be 3 times 1, which is 3. Here, the power 0 will affect everything inside the bracket, so that 3n all raised to power 0 gives 1. The next law is the negative index law, which I grouped into two. The first one is when it's whole, like this, like a whole number, x raised to power minus e, it becomes 1 over x raised to power e. 1 over x raised to power e. And the second one is if your base is a fraction, like in this case, x over y all raised to power minus e, you reciprocate your base so that it becomes y over x. Then there will be no negative sign. You just say all raised to power e. X over y all raised to power minus e is the same thing as y over x all raised to power e. Application, if you want to apply this, let's apply it to solve this. 4 raised to power minus 3. You apply the first one, that is x raised to power minus a, which is 1 over x raised to power a. So it is 1 over 4 raised to power 3. 4 raised to power 3 is 4 times 4 times 4, which is 64. Your answer is not 64, but 1 over 64. 2 over 3 all raised to power minus 3 is the same. You apply the x over y all raised to power minus a, which is y over x all raised to power a. So you reciprocate your base to give you 3 over 2. The negative sign disappears and you have 3 over 2 raised to power 3. 3 raised to power 3 is 27. That is 3 times 3 times 3. 2 raised to power 3 is 8. That is 2 times 2 times 2. So that your final answer becomes 27 over 8. 2y raised to power minus 3. Here, the minus 3 affects only y. And that is why the 2 will remain at the top. So that you have 2 times, applying the first part of law number 4, it will now be 1 over y raised to power 3, just like in this case. The y raised to power minus 3 becomes 1 over y raised to power 3. 2 times 1 is 2 over y raised to power 3. The minus here affects only y. Y here, 2y raised to power minus 3. The minus 3 will affect the two of them, and that is why it will be 1 over everything, all in bracket raised to power 3. Applying this law here, that's 1 over 4 raised to power 3. You say 1 over everything. 2 raised to power 3 is 2 times 2 times 2, which is 8. Y raised to power 3 is 3, and that is why this is 1 over 8y raised to power 3. So in summary, x raised to power a times x raised to power b is x raised to power a plus b. When the bases are same and you are multiplying the indices, write one base, add your powers. X raised to power a divided by x raised to power b is x raised to power a minus b. When you are dividing indices with the same base, write one base, subtract the powers, you say first power minus second power. Anything raised to power 0 is 1. X raised to power minus a is 1 over x raised to power a, like in this case, and also here, where you apply to the y alone. When it's a fraction, x over y raised to power minus a is the same as y over x raised to power a. You reciprocate your base, that's the fraction, so that it becomes y over x. The top number becomes bottom, the bottom number becomes the top. Then the negative sign disappears, like here, becomes 3 over 2 raised to power 3, no minus. Then you simplify to have 27 over 8. And this is how you apply these 4 laws to solve problems. Thank you.